Hello everyone, my name is Ashish Chauhan and I am an academic researcher from SRH Hochschule Heidelberg. And today I am going to present our work titled DWreck, a data record framework for generating unclean datasets. Before going into detail about the framework, I would like to explain the intention behind this framework or the research work. Unclean data or poor quality data costs time as well as money, and data scientists basically analyze the data and clean it based on either missing values or duplicates. Still, the data is of poor quality. Thus, educating the data scientist on different aspects of data cleaning is a must. In our novel framework, we focused on generating unclean dataset, considering data quality dimensions, so that data scientists can educate themselves on these quality dimensions. Let's see how it was achieved. Around $3.1 trillion is the financial impact of poor quality data on businesses in US. And raw data that we receive is vulnerable to noise, outliers, missing values. Since this raw data cannot be consumed directly, a data analysis pipeline is required. According to a paper proposed by Ram and Doe in 2000, a data analysis pipeline comprises of these steps. The steps include data acquisition, data pre-processing, feature engineering, and data interpretation. Data acquisition gives the insights about data sources and data warehouses. Data pre-processing tells us about the cleaning and transforming the data. Feature engineering helps us to select the relevant features, and data interpretation tells us the insights through analyzing and visualizing the data. Looking into data pre-processing in more detail, data pre-processing is an essential step in data analysis pipeline that ensures the data quality is high by detecting the errors, by removing noise. Though data cleaning is an important step, still there are many problems to it. One is it is cost intensive, and second, it is time consuming. Given garbage in, garbage out principle, a dataset with missing values and noise will cause the organization, as the key performance indices will be hampered. For time consuming, around 30 to 80% of the time is just invested for cleaning and transforming the data. So what are the effects of missing or unclean data then? Consider we have to train our neural network and our data is having missing or some invalid values. So while training the data, neural network will learn, the weights will be learned, but those weights might be correct, might not be correct. Therefore, data pre-processing is an important step. The data pre-processing step further involves two steps: data profiling and data cleaning. Data profiling gives the insight about or the column information, and data cleaning is the actual transformation that will be taking place. But going into data cleaning, what exactly is an unclean data? How we can decide the data set that we have is clean or dirty? For those, there are few terminologies that can be used to find out if the data is clean or dirty, and those terminologies are called data quality dimensions. Generally, there are a lot of different terms used in definition of data quality dimension, but as per the article proposed by XM and others in 2013, we will narrow it down to some of the most frequent ones. These include completeness, consistency, validity, accuracy, timeliness, and uniqueness. Now, to clean the data based on these quality dimensions is a must. Out of these, completeness, where we impute missing values, and uniqueness, where we remove the duplicate values, is quite often. But what about others? Therefore, for educating and training data scientists in handling unclean dataset should be present that is already unclean on these quality dimensions, which comes under data generators, and a lot of literature has already been done on data generators. So what is data generation or data generation tools? Data generation is a process that identifies the relevant columns and generates dummy data for those columns using data generators. Since nowadays there are different types of data, which include structured data, unstructured data, semi-structured data, research is performed on data generators for structured data. HTTGen, as proposed by Benning and others in 2006, generates data for the database application considering database schema and embedded SQL queries. Complex databases can be created using data generation language or graph model based tools. Not only has there been exhaustive research on structured data, but also research has been also performed semi-structured data that include XML data or RDF data. For generating XML documents, there are two approaches: schema unaware approach, template based approach. TogsGen, one of the template based generators as proposed by Barbosa and others in 2002, uses template specification language to describe the content of the XML document. But all the relational and XML data generators focused only on generating the data by selecting data from a record space using different statistical distributions. Along with data generators, there are also introduced a corrupter system. The work of corrupter is to unclean the data based on some actions or rules. One of the generator and corrupter system as proposed by Weiss and others in 2006 is Dirty XML generator. The Dirty XML generator modifies the XML document by removing the content by adding duplicates and inserting misspelling using different algorithm. But all these transformations is performed based on some configuration document. In that document, it has to be specified for which column what all transformation needs to be applied. Another is Datum Pipe 2.0. It is also a generator and corrupter system proposed by Samir Al-Janabi and others in 2017 that first generates the data based on some mapping information provided, and then it corrupts the data by applying the data quality dimension in counterproductive way. So what are the limitations in the existing research work? The limitation includes domain-specific generation of unclean data, semi-automation as we require either a document or we require some mapping to be given, and data values are retrieved from an existing record space. Considering this limitation, our contribution is DWreck, a data record framework for generating unclean datasets that is based on microservice based architecture pattern that allows easy extensibility. No additional configuration document is required, as the architecture is having data type processing microservices that will help us to identify what all quality dimensions can be applied in counterproductive way. It's a generic framework where input seed dataset can be of any file format, whether structured or semi-structured, and it can be from any domain. And the same dataset can be used multiple times and can be given to the framework, and every time the framework will give a different output, or we can say a different unclean dataset. But what exactly the framework comprises of? Let's have a look on the architecture of the DWreck framework. As we can see, the DWreck framework is well structured with each functionality as one service, and those are grouped together. So DWreck architecture is a microservice based architecture pattern used where functionality are splitted into microservices, and based on common functionality they are grouped together. Therefore, the architecture is having 4 groups of microservices: data set profiling group of microservices, data type processing group of microservices, counterproductive dimension group, and miscellaneous group. But we can see there are a lot of services. And in order to orchestrate these services so that it can be executed in a proper flow in order to achieve the output, we have a DWreck orchestrator. The task of orchestrator is to orchestrate all the service in a proper manner so that we can get an expected output. But for the orchestrator also, as there is a lot of services, at the end it's a big complex workflow. Therefore, we splitted the complex workflow into 3 sub workflows. For the presentation, we will consider one of the dataset, a snippet of a dataset, and we will go through the complete workflow. Consider a snippet of a comma separated file, a CSV file for student information having 20 plus records. But in the presentation, we will just take 3 records as a snippet. First, this dataset is provided to the orchestrator, and that's the start of the framework. This dataset comprises of 6 columns and it is of different data types. Some are integers, some are strings, some are characters, some are boolean, or some are date. Once the data is provided to the orchestrator, the first and foremost step executed is a microservice executed is database connector. The task of this microservice is to connect the framework to a database so that this complete input dataset is loaded into the database and all the transformation or the actions are performed with the help of a database connection. Once the connection is established, the first data profiling microservice that is executed is pattern matching. So what's the task of pattern matching microservice? It takes a column, identifies the patterns involved in it and the occurrence of that pattern. So for each and every column, it will perform the pattern matching part. Take an example of an age column. So age column is provided to the pattern matching microservice. Pattern matching microservice, we find out the patterns. So we can see in green, patterns is 99, that means it's 2-digit and the occurrence is 145. It can have 999, 3-digit with occurrence sum, then it will have 1-digit and occurrence with some value. In this way, it will find out the patterns and the occurrence of it. The next microservice executed is data type analyzer. It identifies the data type of that particular column. So considering the age column, it can say based on the patterns and the occurrence that the data type of the age column is integer. Next, once we have the patterns and the data type of that column, then the column statistic microservice gives us the statistical information of the column. So with the help of column statistic microservice, information of the column is gathered. For age column, we can see row count and the null count. But those are not only the information. Along with this, there are distinct count, unique values, duplicate count, duplicate values, maximum length for string, minimum length for string, maximum value, minimum value, and so on. For each and every column, all this information of the column statistic is gathered and stored in data profiling document. But that's not only the task of this microservice. Another task of this microservice is to check for each and every record whether it is already uncleaned or not. And it does it by just marking a flag, yes, that is Y, or N, that is no. How it does? If a record is having null value or invalid value, then this microservice says, okay, this record is unclean already, and it marks it as Y. So what's the advantage? In the further serve workflows, that particular record won't be considered. In this way, the dataset is not uncleaned to a large extent that it cannot be recovered. So this record won't be touched, and we will consider some other records for applying the counterproductive quality dimension. This information of the data profiling along with the column stats is then again provided to the orchestrator. And now we are in serve workflow 2, where it identifies what all quality dimensions can be applied counterproductive to a particular column. And this takes place based on the data type of that particular column. So for age column, we saw the data type is integer. So orchestrator will take the information of complete column age with all the data profiling information, the patterns, the stats, and it will provide to the integer microservice. Similarly, for different column data type, different microservice will be executed. Once this microservice executes, it gives us an output which states what all quality dimensions can be applied in counterproductive way on a particular column and how many records needs to be uncleaned or wrecked. From this image, we can see in the blue, for dimension name validity, it is saying status as true and remaining wrecking count as 25. For dimension name accuracy, it is saying status as false, remaining wrecking count as 0. So what it means? For dimension name validity, yes, it's true. That means it needs to be applied in a counterproductive manner. And number of records that needs to be wrecked or uncleaned is 25. For accuracy dimension, it is saying false. That means it shouldn't apply accuracy in a counterproductive manner for that particular column. This information of the data profiling and what all dimension needs to be applied is provided to the orchestrator. Based on the status, whether it is true or false, orchestrator decides which microservice needs to be executed. And since we are applying the dimension in a counterproductive way, the naming convention of the microservice is also in a counterproductive way. That means for validity, invalidity microservice will be executed. For accuracy, inaccuracy will be executed. For completeness, incompleteness, and so on. Then, based on the status, true, false, for each and every column, these microservices are executed. And then the output is again provided to the orchestrator. So what is the output? First output is the unclean data set. That means what all quality dimension is applied in a counterproductive manner on the data set, we are getting an unclean data set at the end. Along with that, the transformation steps that has been executed is also logged. So that if for future reference, then if someone is educating themselves for what quality dimensions, then they can also refer to this logger or transformation logs and can see, okay, these were the quality dimensions that I applied and these were already present. So how much I am able to do it. In this way, they can educate themselves. So what will logger log? It will log all the transformation steps. So if we see the unclean data and the transformation logs, we can see for incompleteness, or that means for completeness quality dimension applied counterproductively. Column name is age, old value was 33 and now it is blank. Same for invalidity. Earlier it was 35, now it is 351. That is an invalid value. And that is done by the framework. Thus, the framework was evaluated on 20 input seed datasets. Those are from different file formats and from different domains. But how we can evaluate the framework? For that, we use data quality score that help us to find out what is the quality of the data set, what we have. For that, it considers the wrecked or unclean data in it and the number of records present. After the execution of the framework, we can see an evaluation table in this manner. We can see at the bottom, seed dataset, which is the name. It says student.csv. Yes, it is a student data. Number of records, it is 22,232. Rect record already present. That means already unclean data, which is unclean record, which are present in the dataset. It is 292. It might be due to missing values or invalid values. After that, wrecked records by framework. How many records were actually wrecked by the framework? D1, D2, D3, D4 and D5 are the quality dimensions based on which it was applied counterproductively and how many records were wrecked on those quality dimensions. So we can see for D1, it is saying 100125 and so on, where D1 is for incompleteness, D2 is for inconsistency, D3 for inaccuracy, D4 for invalidity, and D5 for duplicates. And above that, total we can see 4421 records were uncleaned by the framework. Then the number of records, we can see it is 23,357. We can say how it has been increased. Because since we are applying uniqueness in a counterproductive way, that means duplicates. And D5 is saying duplicates. 1125 is the duplicate count. If we sum up the number of records which are already there and the duplicates, it comes out to be 23,357. Then comes the two important columns, DQA and DQF. DQA is the data quality score before passing it to the framework, and DQF is the data quality score after passing through the framework. DQA is 98.68%. That means 98.68% data was cleaned in that data set. And DQF is the data quality of that data set after passing through the framework. It is 81.07. That means 81.07 records or percent of data is unclean now. So we can see there is a decrease in the data quality, and that was what we want from the framework, to decrease the quality of data but considering the quality dimensions. Now I want to conclude by mentioning that DWreck or data record framework for generating unclean dataset will help to educate and train the data scientists in handling unclean data. It is a microservice based architecture for easy extensibility, and dataset that is generated, that is unclean data, is achieved by applying quality dimension in counterproductive way. What are the results provided by DWreck? First, the unclean data set on different quality dimensions applied counterproductively. Second, transformation logs to prepare unclean data set for provenance. So I would like to end my talk for the presentation, and thank you for your attention.